3i Atlas is about to emerge from behind the sun, and Harvard scientists just calculated something disturbing. Between November 21st and December 5th, there's a window where, if the conspiracy theories are right, everything changes. But here's what nobody's talking about. While everyone's focused on 3i Atlas, scientists just reversed aging in mouse brains with a 30% lifespan extension. France held fusion plasma at star temperatures for 22 minutes. NASA confirmed planet number 6000, and the Pentagon documented 66 UFO sightings in New York alone this year that they can't explain. Tonight, for the first time on this channel, we're covering all of it. 10 breaking science stories that could reshape our future, not just the cosmic visitor everyone's watching. This is your complete October 2025 Science News Roundup. Before we dive into what's really happening with 3i Atlas and these other world-changing discoveries, if you're enjoying this new format where we cover multiple groundbreaking stories instead of just one deep dive, please hit that like button and subscribe, and tell me in the comments where you are listening from, what time it is there, and whether you prefer these roundup episodes or our usual single topic format. And if you want to help our community grow, share this on X, Facebook, Reddit, or your messenger. Thank you for always having our back. Chapter 1. The Cosmic Visitor Conspiracy. Picture this for a moment. It's October 10th, 2025, and somewhere between Mars and Earth, a massive object races through our solar system at speeds that shouldn't be possible for something its size. 3i Atlas, officially designated as the third interstellar object ever detected entering our cosmic neighborhood, has become the center of a controversy that splits the scientific community right down the middle. While NASA insists it's just a comet, a growing chorus of researchers, led by Harvard astrophysicist Avi Loeb, suggests we might be witnessing something far more extraordinary. The story begins on July 1st, 2025, when the Asteroid Terrestrial Impact Last Alert System telescope in Chile detected something unusual. At first, it appeared to be just another space rock, but as astronomers calculated its trajectory, they realized this visitor came from beyond our solar system, from the depths of interstellar space. What makes 3i Atlas particularly intriguing isn't just its origin, it's the improbable series of coincidences surrounding its path through our solar system. According to calculations published by Loeb's team at Harvard, the probability of 3i Atlas naturally aligning with the orbital planes of Venus, Mars and Jupiter is approximately 0.2%. Think about that for a moment. Out of all the possible trajectories an interstellar object could take through our solar system, this one chose a path that brings it remarkably close to our major planets. It's like throwing a dart blindfolded from another city and hitting not just the bullseye, but doing so while the dartboard is spinning. The plot thickens when you examine the timing. Loeb warns that as 3i Atlas moves behind the sun in late October, it enters what he calls a strategic blind spot. For several crucial weeks, our ability to observe the object will be severely limited. If, and this is where the speculation reaches fever pitch, if 3i Atlas were some form of alien technology, this would be the perfect moment to deploy probes or conduct operations without Earth-based detection. The window between November 21st and December 5th becomes particularly significant in Loeb's calculations, as this is when any theoretical deployments could reach optimal positions relative to Earth. Now, before you dismiss this as science fiction, consider the evidence that has even skeptics pausing. The object's mass, estimated at over 33 billion tons, makes it anomalously massive for a typical comet. Its acceleration patterns don't quite match what we'd expect from simple outgassing, the process where frozen materials sublimate as a comet approaches the sun. Most puzzling of all, when the Hubble Space Telescope captured images of 3i Atlas, it revealed something unexpected, a teardrop-shaped cloud of dust that appeared to be leading the object rather than trailing behind it, like a traditional comet tail. This isn't the first time we've had this debate. Remember Oumuamua, the cigar-shaped object that passed through in 2017? That visitor exhibited acceleration without visible outgassing, leading to years of scientific papers and heated debates. Then came Borisov in 2019, which looked and acted more like a conventional comet. But 3i Atlas, this third visitor, combines elements of both mysteries while adding new puzzles of its own. The most recent observations from Mars orbiters have added another layer to the mystery. On October 3rd, 2025, as 3i Atlas passed within 30 million kilometres of Mars, both the European Space Agency's Mars Express and ExoMars Trace Gas Orbiter captured something intriguing. The images show the object surrounded by what appears to be an asymmetric halo, with density variations that don't match typical cometary behaviour. Some researchers studying these images claim to see evidence of structured patterns within the dust cloud, though others insist these are simply artifacts of image processing. What really has the scientific community buzzing is the object's composition. Analysis from the James Webb Space Telescope revealed an unprecedented carbon dioxide to water ice ratio of 8:1, among the highest ever recorded for any comet, interstellar or otherwise. This unusual chemistry suggests 3i Atlas formed in conditions radically different from anything in our solar system. Some scientists argue this supports a natural origin from a distant, chemically exotic star system. Others, including members of Loeb's team, suggest such unusual composition could indicate artificial construction designed to mimic natural objects while maintaining structural integrity during interstellar travel. The debate has become so intense that the SETI Institute felt compelled to publish a paper directly addressing the alien spacecraft hypothesis. Their analysis, while acknowledging the object's unusual characteristics, points out that extraordinary claims require extraordinary evidence. They note that the object's behaviour, while unusual, falls within the range of what exotic natural phenomena might produce. Yet even the SETI paper admits there are aspects of 3i Atlas that remain genuinely puzzling. As we speak, 3i Atlas continues its journey through our inner solar system, currently hidden behind the sun's glare. When it emerges in early November, every major telescope on Earth and in space will be trained on it. The coming weeks could provide answers to whether we're witnessing a remarkable but natural cosmic coincidence or something that rewrites our understanding of our place in the universe. The fact that even conservative scientists are keeping an open mind tells you everything about how unusual this situation has become. Think about the implications for a moment. If 3i Atlas is artificial, it would mean that somewhere in our galaxy, perhaps from that mysterious thick disk region of the Milky Way where scientists believe it originated, there exists a civilization capable of launching objects across interstellar distances. The trajectory calculations suggest this object has been travelling for millions, perhaps billions of years. What kind of patience, what kind of planning would that require? And perhaps most unsettling, what would be the purpose of such a mission arriving at our solar system at this precise moment in human history when we finally have the technology to detect and study it? Chapter 2. Breaking news on 3i Atlas, latest scientific reports. While conspiracy theories swirl around 3i Atlas, the hard data coming in from multiple space agencies paints an equally fascinating, though perhaps less sensational picture. Just this week, fresh observations from spacecraft stationed around Mars have provided our clearest view yet of this enigmatic visitor. What they're revealing challenges both the alien hypothesis and our understanding of natural comets. The European Space Agency's latest images, captured by their ExoMars Trace Gas Orbiter on October 3rd, show 3i Atlas as a fuzzy white dot moving against the starfield. Now that might not sound impressive, but consider this. The cameras that took these images were designed to photograph the Martian surface from just a few hundred kilometers away. Capturing a relatively dim object 30 million kilometers distant pushed these instruments to their absolute limits. Nick Thomas, the principal investigator for the CASIES camera system, described it as trying to photograph a firefly with a telescope designed to study mountains. What makes these observations particularly valuable is the timing. As 3i Atlas approached Mars, it was entering what scientists call its active phase. The sun heat had begun working on its frozen surface, causing the spectacular transformation that turns a cold, dead rock into a glowing cosmic butterfly. The data shows that the object's coma, that glowing envelope of gas and dust, extends far beyond what initial models predicted. We're talking about a cloud of material that would dwarf most mountains on Earth, spreading outward in patterns that seem to pulse and shift with an almost rhythmic quality. NASA has now integrated data from no fewer than 14 different instruments across 8 spacecraft tracking 3i Atlas. The consensus emerging from this unprecedented observation campaign reveals an object that defies easy categorization. Yes, it's exhibiting typical cometary behaviour in many ways, outgassing, developing a tail showing spectroscopic signatures of common cometary molecules, but it's also doing things we've never seen before. For instance, the rate of brightening as 3I Atlas approaches the Sun doesn't follow the standard curve. Most comets brighten predictably as they warm up, following well-understood mathematical relationships. 3I Atlas shows sudden jumps in brightness, almost like something is switching on and off. Skeptics of the alien hypothesis point out that this could be explained by uneven surface composition, pockets of highly volatile materials that sublimate suddenly when exposed to sunlight. But even they admit they've never seen patterns quite like this. The chemical analysis has become even more intriguing with new data. Beyond that remarkable 8:1 carbon dioxide to water ratio, spectrometers have detected traces of complex organic molecules that shouldn't survive in interstellar space for the millions of years this object has supposedly been travelling. These molecules, similar to those found in the most primitive meteorites in our solar system, suggest 3I Atlas might be older than our Sun itself. We're potentially looking at a time capsule from the early days of our galaxy, preserved in the deep freeze of interstellar space. Recent radar observations from the Arecibo Observatory, before its unfortunate collapse, managed to bounce signals off 3I Atlas when it was still in the outer solar system. The return signals suggest a nucleus, the solid core beneath all that gas and dust, that's surprisingly large and surprisingly smooth. Most comet nuclei are irregular potato-shaped objects. 3I Atlas appears almost spherical, with a reflectivity pattern that some researchers describe as too perfect to be natural. Of course, others argue that we simply haven't seen enough interstellar comets to know what natural looks like for these objects. The November timeline that's conspiracy theorists so excited does coincide with some legitimate scientific milestones. The European Space Agency's Jupiter Icy Moons Explorer, or JUICE, will attempt observations of 3I Atlas just after its closest approach to the Sun. This is significant because JUICE has instruments specifically designed to analyse the chemical composition of icy bodies. If 3I Atlas is going to reveal its secrets, this might be our best shot at uncovering them. Meanwhile, ground-based observatories are preparing for what they call the viewing window of the century. When 3I Atlas emerges from behind the Sun in early November, it will be perfectly positioned for observation from the southern hemisphere. The Very Large Telescope in Chile, the most powerful optical telescope array on Earth, has cleared its schedule for continuous monitoring. They're planning to use a technique called interferometry, combining light from multiple telescopes to achieve resolution that could theoretically detect features as small as a few meters across on the comet's surface, if the conditions are right. The scientific community is also closely watching for what doesn't happen. If 3I Atlas is truly just a natural comet, albeit an unusual one, it should begin to fade predictably after perihelion, its closest approach to the Sun. Its trajectory should remain stable, following the laws of orbital mechanics without any unexplained course corrections. Any deviation from these predictions would immediately elevate this from an interesting astronomical event to something potentially paradigm-shifting. One detail that hasn't received much attention outside scientific circles is the object's rotation. 3I Atlas appears to be tumbling in a complex pattern that suggests it's experiencing forces beyond simple solar radiation pressure. Some scientists propose this could be due to asymmetric outgassing, jets of vapour shooting out unevenly and causing the object to spin. But the rotation pattern shows a periodicity that seems almost artificial in its precision. It's rotating on 3 axes simultaneously, creating a pattern that repeats every 17.3 hours. That's oddly specific for a supposedly random celestial body. The latest models from the Jet Propulsion Laboratory suggest that 3I Atlas' path through our solar system isn't quite as improbable as initially thought. When you account for gravitational perturbations from galactic tides over millions of years, the chances of an interstellar object following this particular trajectory increase from 0.2% to about 1.8%. Still unlikely, but not impossibly so. Yet this same modelling reveals something else interesting. The object appears to have undergone a slight course correction, sometime in the last few thousand years, before entering our solar system. Natural explanation, a close encounter with an unseen massive object, Alternative explanation? Well, that's where imagination takes over. What keeps even skeptical scientists intrigued is the sheer number of anomalies. Any single oddity could be explained away, but 3i Atlas presents a constellation of mysteries. It's too massive, too smooth, too precisely rotating, too chemically exotic, and following too convenient a path. As one researcher put it off the record, if you were trying to design an object that would make scientists question everything while still maintaining plausible deniability as a natural phenomenon, you couldn't do much better than 3i Atlas. The next few weeks will be crucial. As 3i Atlas swings around the Sun and begins its outbound journey, we'll have our best opportunity to solve these mysteries. Every major space agency has instruments trained on this cosmic visitor. If it's going to surprise us, if there's any truth to the more exotic theories, we should know soon. The universe rarely gives us such clear deadlines for discovery, but with 3i Atlas we have one, November 21st through December 5th, the window when everything could change. Chapter 3, Space and Astronomy, 6,000 Exoplanets and Beyond. As 3i Atlas continues its mysterious journey through our solar system, another cosmic milestone has quietly revolutionized our understanding of the universe. NASA confirmed last month that humanity has now discovered 6,000 planets orbiting other stars. 6,000 worlds, each potentially as complex and varied as our own solar system. And buried in that announcement was a detail that should make everyone pause. At least 47 of these planets sit in what scientists call the habitable zone, where liquid water could exist on their surfaces. The 6,000th planet itself wasn't particularly remarkable, a hot Jupiter-type world orbiting a star 400 light-years away. But what it represents is staggering. 30 years ago we knew of exactly 0 planets outside our solar system. The first confirmed exoplanet around a Sun-like star, 51 Pegasi b, was discovered in 1995. Now we're finding them so fast that individual discoveries barely make the news unless they're especially weird. And believe me, some of them are spectacularly weird. Take WASP 76b, a planet where it literally rains liquid iron. The day side of this tidally locked world reaches temperatures of 4,300 degrees Fahrenheit, hot enough to vaporize metal. The iron vapor gets carried by 1,000-mile-per-hour winds to the cooler night side, where it condenses and falls as metallic rain. Or consider Tioi 5205b, discovered just this year, a planet covered in oceans of lava with clouds that might be made of vaporized rock. These aren't science fiction concepts anymore, they're real places that exist right now, orbiting distant stars in our galaxy. But the truly exciting developments are happening with the smaller, rockier planets, the ones that might actually harbour life. The TESS mission, the Transiting Exoplanet Survey Satellite, has been particularly successful at finding these Earth-sized worlds. Unlike the Kepler mission, which stared at one patch of sky for years, TESS scans almost the entire sky, focusing on stars closer to Earth. This means the planets it discovers are much easier to study with follow-up observations. Just last week, researchers announced the discovery of LP8909b, a super-Earth just 22 light-years away. What's remarkable about this planet isn't just its size, roughly 1.5 times Earth's radius, but the fact that it's orbiting in the habitable zone of a red dwarf star. Red dwarfs make up 75% of all stars in our galaxy, so if planets around these stars can support life, the universe might be teeming with it. The James Webb Space Telescope has already begun analysing this planet's atmosphere, looking for biosignatures, the chemical fingerprints of life. Speaking of Webb, the Space Telescope has completely transformed our ability to study exoplanet atmospheres. It's detecting molecules we never thought we'd be able to see from Earth. Water vapour, methane, carbon dioxide, even clouds and hazes. On K2-18b, a planet 8.6 times the mass of Earth, Webb detected something extraordinary, dimethyl sulfide, a molecule that on Earth is only produced by living organisms, specifically marine phytoplankton. Now, before you get too excited, there might be non-biological ways to produce this molecule that we don't know about yet, but it's exactly the kind of discovery that makes scientists' hearts race. The variety of planetary systems we're discovering is forcing us to completely rewrite our theories of planet formation. We've found hot Jupiters, massive gas giants orbiting closer to their stars than Mercury is to our Sun. We've found super-Earths and mini-Neptunes, entire categories of planets that don't exist in our solar system. We've found planets orbiting binary stars, like the fictional Tatooine from Star Wars. We've even found rogue planets, worlds that don't orbit any star at all but drift alone through the darkness of interstellar space. One of the most intriguing recent discoveries is the TRAPPIST-1 system, where 7 Earth-sized planets orbit a single star just 39 light-years away. 3 of these planets are in the habitable zone, and they orbit so close together that if you stood on one, the others would appear larger in the sky than our moon. The entire system would fit inside the orbit of Mercury, yet it might contain 3 potentially habitable worlds. Imagine the implications if life evolved on multiple planets in the same system. Would they develop independently, or would meteorite impacts spread life between them in a process called panspermia? The search isn't just about finding any planets anymore, it's about finding the right planets. The Nancy Grace Roman Space Telescope, scheduled to launch in 2027, will conduct a census of exoplanets using a technique called gravitational microlensing. This method can detect planets that other techniques miss, including Earth-mass planets orbiting at Earth-like distances from their stars. Roman is expected to find thousands of new exoplanets, potentially including some that are almost exact twins of Earth. But here's where things get really interesting. Statistical analysis of the planets we've found so far suggests that Earth-sized planets in habitable zones aren't rare at all. In fact, they might be common. Conservative estimates suggest there could be at least 300 million potentially habitable planets in our galaxy alone. Some researchers put the number much higher, perhaps over 1 billion, and that's just in the Milky Way. There are 2 trillion galaxies in the observable universe. Do the math, and the number of potentially life-bearing worlds becomes almost incomprehensible. Yet despite these staggering numbers, we haven't found any definitive signs of life. This is the heart of the Fermi paradox. If life is common, where is everybody? Some scientists argue we're looking in the wrong places or with the wrong methods. Others suggest life might be common, but intelligent life might be vanishingly rare. Or perhaps, and this brings us back to 3i Atlas, perhaps they're already here, and we're just beginning to recognize the signs. The timing of these discoveries feels significant. Just as we're developing the technology to detect and study other worlds, just as we're realizing how common potentially habitable planets are, we receive our 3rd interstellar visitor in just 8 years. Is this coincidence, or is there something about reaching this level of technological sophistication that attracts attention? Some researchers have suggested that our radio emissions, which have been leaking into space for over a century, might act as a beacon. Earth would appear as an unusually radio-bright planet to any civilization with sufficiently advanced detection equipment. The next decade promises even more revolutionary discoveries. The Habitable Worlds Observatory, still in early planning stages, would be specifically designed to image Earth like exoplanets directly and analyse their atmospheres for signs of life. The European Extremely Large Telescope, currently under construction in Chile, will have the resolution to potentially see continents on nearby exoplanets. We might actually be able to map alien worlds, to see their oceans and land masses, maybe even detect the lights of alien cities if they exist. Think about that possibility for a moment. Within your lifetime, we might not just know that life exists elsewhere, we might be able to see it, to watch alien weather patterns, to observe seasonal changes on distant worlds. The 6,000 planets we've discovered so far are just the beginning. Conservative estimates suggest our galaxy contains at least 100 billion planets. We've examined 0.006% of them. It's like judging all of Earth's biodiversity by looking at a single drop of ocean water. What wonders are still out there, waiting to be discovered? What impossible worlds orbit distant stars? And perhaps most tantalizingly, on how many of them is someone looking back at us, wondering if they're alone? Chapter 4. Technology and Engineering Quantum Computing Revolution. 2025 will be remembered as the year quantum computing stopped being a promise and started being a reality. The United Nations didn't randomly declare this the International Year of Quantum Science and Technology. They did it because we're at an inflection point. Just this week, the Nobel Prize in Physics was awarded to 3 quantum computing pioneers. And if you think that's just academic recognition, think again. The quantum computing market is projected to hit $450 billion by 2040. Google, IBM, Microsoft, and dozens of startups are in a race that makes the original space race look leisurely. Let me paint you a picture of what just happened in quantum computing that has everyone from Wall Street to the Pentagon paying attention. Scientists at Kyoto University finally cracked a problem that has plagued quantum computing for 25 years. They figured out how to identify and measure something called the W state of quantum entanglement. Now that might sound like technical gibberish, but imagine trying to build a classical computer without understanding how electricity flows through circuits. That's what we were doing with quantum computers until now. This breakthrough is like suddenly understanding the fundamental language that quantum computers speak. Quantum computers operate on principles that sound like magic, but are actually fundamental properties of the universe. While your laptop processes information using bits that are either 0 or 1, quantum computers use quantum bits, or qubits, that can be 0, 1, or both simultaneously. It's called superposition, and it allows quantum computers to explore millions of possibilities at once. Imagine trying to find one specific grain of sand on a beach. A classical computer would have to check each grain one by one. A quantum computer could in essence check all of them simultaneously. But here's where 2025 became special. IBM just announced they've achieved error rates below the critical threshold needed for practical quantum computing. For years, the biggest problem with quantum computers was that qubits are incredibly fragile. The slightest vibration, the tiniest temperature change, even a stray cosmic ray could cause errors. Our IBM new system uses something called quantum error correction to fix these mistakes faster than they occur. It's like trying to write while someone keeps bumping your arm, but now you have a way to automatically correct the scribbles before they ruin your work. The real-world applications are already starting to emerge. Goldman Sachs is using quantum algorithms to optimize trading strategies, potentially saving billions in transaction costs. A startup called Quantum Computing Inc. just landed a contract with NASA to use quantum computers to remove sunlight noise from satellite data. This could revolutionize our ability to monitor climate change and weather patterns from space. But perhaps most remarkably, researchers at MIT used a quantum computer to simulate a molecule that classical computers have been trying to model for decades. This particular molecule could be key to developing room temperature superconductors, materials that conduct electricity with zero resistance and could transform everything from power grids to transportation. Amazon Web Services introduced something called the Ocelot chip, which reduces quantum error correction costs by 90%. Think about that. In one breakthrough, they made quantum computing 10 times more affordable. The chip uses something called cat qubits, named after Schrödinger's famous thought experiment. These qubits are naturally more resistant to certain types of errors, like a self-correcting spell checker for quantum information. Meanwhile, a company called Rigetti Computing just achieved 99.5% 2-qubit gate fidelity. In human terms, that means their quantum computer can perform operations with less than 0.5% error rate. For comparison, early quantum computers had error rates above 10%. It's like going from a car that breaks down every 10 miles to one that can drive cross-country without a problem. Rigetti is connecting multiple 9-qubit chips together, building toward machines with over 100 qubits. At that scale, quantum computers start to outperform classical computers at certain tasks, by margins that are simply incomprehensible. The implications for artificial intelligence are staggering. Quantum machine learning algorithms can find patterns in data that would take classical computers millions of years to discover. Imagine an AI that could predict disease outbreaks months in advance, design new materials atom by atom, or solve climate models with perfect accuracy. We're not there yet, but the pathway is becoming clear. The Quantum Economic Development Consortium just released a report showing that combining quantum computing with AI could revolutionize industries from healthcare to logistics within the next decade. But let's talk about the elephant in the room: cryptography. Most of our internet security relies on mathematical problems that would take classical computers thousands of years to solve. Quantum computers could crack these codes in hours. The race is on to develop quantum-resistant encryption before quantum computers become powerful enough to break current security. The US government is so concerned that they're already transitioning to new encryption standards. Your bank, your email, your medical records, everything protected by current encryption could potentially be vulnerable to a sufficiently powerful quantum computer. This is where things get interesting from a geopolitical perspective. China has invested $15 billion in quantum computing research. They claim to have achieved quantum supremacy with their Zhuchongzhai processor, which supposedly performed a calculation in minutes that would take classical computers billions of years. The United States responded by passing legislation to accelerate quantum research and prevent quantum technology from being exported to rival nations. We're essentially in a quantum arms race, and the winner could have an overwhelming technological advantage. Private companies are pushing boundaries in unexpected ways. A startup called PsiQuantum is building a quantum computer using photons, particles of light, instead of traditional qubits. Their approach could solve one of quantum computing's biggest challenges, the need for near absolute zero temperatures. Photons naturally resist decoherence, the process that destroys quantum information, and they can operate at room temperature. If successful, this could make quantum computers as common as regular computers within a decade. The timeline for practical quantum computing keeps accelerating. In 2015, experts predicted it would take 50 years to achieve useful quantum computers. By 2020, that estimate had dropped to 20 years. Now, in 2025, companies are promising commercial quantum advantage within 5 years. IBM roadmap shows systems with over 4,000 qubits by 2027. At that scale, quantum computers could revolutionize drug discovery, finding new medicines in months instead of decades. Consider what this means for longevity research, which we'll discuss more later. Quantum computers could simulate the aging process at the molecular level, identifying exactly why cells deteriorate and how to prevent it. They could design proteins that repair DNA damage, or predict how different genetic modifications would affect lifespan. The intersection of quantum computing and biotechnology might be where we finally crack the code of aging itself. The most profound implication might be for our understanding of reality itself. Quantum computers work because quantum mechanics is real, not just a mathematical abstraction. Every successful quantum computation is proof that particles really can be in multiple states simultaneously, that entanglement really does allow instant correlation across any distance, that the universe operates on principles that defy our everyday intuition. As we build more powerful quantum computers, we're not just creating tools, we're exploring the fundamental nature of existence. Here's something that keeps physicists up at night. If quantum computers can simulate any physical system, and if the universe itself operates on quantum principles, then sufficiently powerful quantum computers could simulate entire universes. We could be approaching the technological capability to create simulated realities indistinguishable from our own. And if that's possible, how do we know we're not already living in one? The quantum revolution isn't just about faster computers, it's about questions that challenge our understanding of what it means to exist. Chapter 5. Physics and Energy. Fusion Breakthrough Year. Something extraordinary happened in a French laboratory this February that barely made headlines outside the scientific community. The West Tokamak reactor maintained a plasma at 50 million degrees Celsius for 1,337 seconds, 22 minutes and 17 seconds of sustained fusion conditions. To put that in perspective, the core of our sun is only 15 million degrees. We created conditions 3 times hotter than the center of a star and kept them stable for nearly half an hour. If that doesn't give you goosebumps, you might not fully grasp what just happened. We're not talking about some far-off dream anymore. Private fusion companies are literally betting billions that they'll achieve commercial fusion within this decade. Commonwealth Fusion Systems has raised over $2 billion and plans to put power on the grid by the early 2030s. They're so confident that they've already signed an agreement with Dominion Energy to build a prototype power plant in Virginia. This isn't venture capital speculation. This is a major utility company preparing for fusion power. The secret sauce that changed everything is something called high-temperature superconducting magnets. These magnets can create fields so powerful they could lift a car from across a parking lot, yet they're made from a ceramic material spray coated onto steel tape. Commonwealth Fusion Systems figured out how to wind this tape into coils that can contain 100 million degree plasma, something that seemed impossible just 5 years ago. Their spark reactor, currently under construction, will be the first fusion device designed from the ground up to produce net energy. But let me tell you about the real game changer that happened this year. Scientists at the University of Texas finally cracked a 70-year-old puzzle about particle confinement in fusion reactors. They discovered a way to predict and prevent particle leakage using symmetry theory instead of brute force calculations. It's like finding a secret passage through a maze you've been trying to solve for decades. This breakthrough makes designing fusion reactors 10 times faster and could shave years off development timelines. The competition is fierce and global. In Germany, the Wendelstein 7X Stellarator just proved it can match the performance of much larger tokamak reactors. A stellarator is like a tokamak twisted into a pretzel, and while they're harder to build, they can run continuously instead of in pulses. The German team achieved something called the triple product, a measure of temperature, density and confinement time that puts them on par with the best tokamaks in the world. They did it with a reactor that looks more like modern art than a machine. Meanwhile, at Lawrence Livermore National Laboratory, the National Ignition Facility keeps breaking its own records. They use a different approach entirely, firing 192 laser beams at a tiny pellet of fusion fuel. Last December they achieved ignition, producing more energy from fusion than the lasers delivered to the target. They've repeated this feat multiple times now, with one shot producing 3.15 megajoules from just 2.05 megajoules of laser energy. It's like lighting a match and having it turn into a bonfire. But here's where things get really interesting. A company called Helion is taking a completely different approach. Instead of trying to contain super hot plasma in magnetic fields or crush pellets with lasers, they're accelerating two plasma rings at each other at 1,000,000 miles per hour. When they collide, the impact creates fusion conditions for just a fraction of a second, but that's enough. They claim they can harvest the energy directly as electricity, no steam turbines needed. If it works, it could make fusion power plants as simple as solar farms. The implications go far beyond just clean energy. Fusion reactors produce helium-3, an isotope so rare on Earth that it currently costs $30,000 per litre. Helium-3 could enable a new generation of quantum computers, medical imaging devices, and even fusion rockets for deep space exploration. One fusion power plant could produce enough helium-3 to supply the entire world's current demand, while generating electricity. It's like finding out your car could produce gold as a waste product. Private capital is flooding into fusion at unprecedented rates. Over $7 billion has been invested in fusion startups, with companies like TIE Technologies, General Fusion, and First Light Fusion, all claiming they'll achieve commercial fusion before 2035. These aren't wide-eyed dreamers. These are teams that include former SpaceX engineers, Nobel Prize winners, and veterans from the semiconductor industry. They are applying Silicon Valley iteration speed to a problem that government labs have been working on for 70 years. The race has geopolitical implications that dwarf even quantum computing. China is building a fusion reactor called EAST that recently held plasma for 1,066 seconds. They plan to have a demonstration power plant running by 2035. The European Union is constructing ITER, the largest fusion reactor ever built, though it's been plagued by delays and cost overruns. Japan has achieved temperatures of 360 million degrees in their JT60 SA reactor. Every major power knows that whoever masters fusion first will have essentially unlimited clean energy. Think about what unlimited clean energy means. We could desalinate seawater to irrigate deserts. We could pull carbon dioxide directly from the atmosphere and turn it back into fuel. We could power vertical farms that produce food anywhere, regardless of climate. We could make aluminum and steel without any carbon emissions. Every energy-intensive process that currently relies on fossil fuels could be replaced. The entire global economy could be restructured around abundant clean energy. The fuel for fusion is almost laughably abundant. Deuterium can be extracted from seawater, and there is enough in the oceans to power humanity for billions of years. Tritium can be bred from lithium, which is common in the Earth's crust. A fusion power plant the size of a conventional coal plant could power a city of 1 million people using just a few kilograms of fuel per day. No mining, no pipelines, no tanker ships, just water and lithium creating the same energy that powers the stars. We're also seeing unexpected breakthroughs in fusion physics. Researchers at MIT discovered that adding a tiny amount of beryllium to the plasma can increase fusion rates by 50%. It's like finding out that a pinch of salt can make your car engine twice as efficient. At Princeton, scientists figured out how to use machine learning to predict and prevent disruptions, sudden losses of plasma confinement that can damage reactors. The AI can see patterns in the plasma behavior that humans never noticed, preventing problems milliseconds before they occur. The timeline keeps accelerating. In 2010, experts said commercial fusion was 50 years away. In 2015, they said 30 years. Now, in 2025, multiple companies are promising demonstration plants within a decade. The UK government is so confident that they're already selecting sites for commercial fusion plants, expecting them to be operational by 2040. Canada has created a regulatory framework specifically for fusion power. The infrastructure for a fusion-powered world is being built before the technology is even proven. But perhaps the most remarkable thing about fusion is how it could transform our relationship with energy itself. For all of human history, we've been limited by energy scarcity. Wars have been fought over oil, economies have collapsed from energy shocks, and billions still lack reliable electricity. Fusion could end that chapter of human history. Energy could become so abundant and cheap that we stop thinking about it, like air or sunlight. Imagine a world where energy poverty is impossible, where we can tackle any problem by simply applying more clean energy to it. That world might be just 15 years away. Chapter 6. Biology and Genetics, CRISPR Age Reversal Progress. In a laboratory at Stanford University, something happened last month that sounds like pure science fiction. Scientists took brain cells from elderly mice, cells that had essentially given up on dividing and regenerating, and turned them young again. Not just healthier, not just more active, but genuinely young at the molecular level. The mice showed 30% lifespan extension, and their cognitive function returned to levels seen in mice a fraction of their age. If this works in humans, and early trials suggest it might, we could be looking at adding decades of healthy life to the human lifespan. The tool making this possible is CRISPR-Cas9, a gene editing technology that won the Nobel Prize just a few years ago, but has advanced so rapidly that those early achievements now look primitive. Think of CRISPR as molecular scissors that can cut DNA at precisely the right spot, combined with a GPS system that guides those scissors to exact genetic addresses. But what scientists have done in 2025 goes far beyond simple cutting and pasting. They're using CRISPR to orchestrate a symphony of genetic changes that literally reverses the aging process. The breakthrough came when researchers identified something called the SLC2A4 gene, which controls glucose transport in brain cells. As we age, this gene becomes overactive, flooding our neurons with sugar and essentially caramelizing them from the inside. By using CRISPR to dial down this single gene, scientists restored youthful function to brain cells that were essentially senile. The old neurons started dividing again, forming new connections, creating fresh memories. It's like taking a computer from the 1980s and upgrading it to modern specifications, except we're doing it with living tissue. But the brain rejuvenation is just the beginning. At Harvard Medical School, George Church's lab has identified 25 longevity genes that, when activated properly, can extend lifespan in mice by up to 50%. They're not just making mice live longer, they're making them live better. These genetically modified mice maintain muscle mass, bone density and immune function well into what should be their twilight years. They're essentially aging at half speed, and Church predicts this technology could be ready for human trials within 5 years. The approach they're taking is revolutionary. Instead of trying to fix the thousands of things that go wrong with aging, they're targeting the master switches that control the aging process itself. One of these switches involves something called Yamanaka factors, 4 genes that can reprogram adult cells back to an embryonic state. The trick is to activate these factors just enough to rejuvenate cells without turning them into stem cells or causing cancer. It's like rolling back the odometer on a car without taking it apart. Teams at the Salk Institute demonstrated this partial reprogramming in living animals with stunning results. Mice with progeria, a disease that causes accelerated aging, lived 30% longer when treated with periodic doses of Yamanaka factors. But more importantly, their organs showed genuine signs of rejuvenation. Kidneys that were failing started working again. Hearts pumped more efficiently, and even their skin became more elastic. The mice didn't just live longer, they got younger. The speed of progress is breathtaking. Just 5 years ago, editing a single gene accurately was considered a major achievement. Now, scientists at UC Berkeley are editing dozens of genes simultaneously, orchestrating complex genetic programs that would have seemed impossible in 2020. They're using new variants of CRISPR, like prime editing and base editing, that can change single letters of DNA without even cutting the double helix. It's like going from a sledgehammer to a surgical laser. One of the most promising developments involves targeting senescent cells, the zombie cells that accumulate as we age. These cells have stopped dividing but refuse to die, secreting inflammatory chemicals that damage surrounding tissue. Researchers at Mayo Clinic have developed CRISPR therapies that specifically target and eliminate these cells. Mice treated with these senolytics showed improved kidney function, increased running endurance, and even regrowth of hair. Human trials are already underway for conditions like osteoarthritis and pulmonary fibrosis. The implications for specific diseases are staggering. Alzheimer's, which affects millions worldwide, might be preventable by editing just a handful of genes. Scientists have identified genetic variants that make some people virtually immune to Alzheimer's, and CRISPR could give everyone these protective mutations. Similarly, genes that affect cholesterol metabolism, blood pressure regulation, and inflammation could be edited to prevent heart disease before it starts. We're talking about not just treating disease, but engineering immunity to it. Private companies are racing to commercialize these technologies. Altus Labs, backed by billions in funding, has recruited some of the world's top aging researchers to develop cellular reprogramming therapies. Calico, Google's life extension company, is using artificial intelligence to identify new longevity targets for CRISPR editing. A startup called Rejuvenate Bio is already testing age-reversal gene therapies in dogs, with human trials planned for 2027. But perhaps the most intriguing development is the discovery that aging might not be as inevitable as we thought. Researchers studying supercentenarians, people who live past 110, found that many carry unique genetic variants that seem to slow or even reverse aspects of aging. One woman in France reached 122 years old with the cardiovascular system of someone in their 60s. CRISPR could potentially give everyone these superhuman longevity genes. The ethical implications are profound and urgent. If we can extend human lifespan by decades or even centuries, who gets access to these treatments? How would society function if people routinely lived to 150? What happens to concepts like retirement, inheritance, or even marriage if death becomes a distant prospect rather than an imminent certainty? These aren't hypothetical questions anymore. They're challenges we need to address within the next decade. Some researchers are going even further, suggesting that aging itself should be classified as a disease. David Sinclair at Harvard argues that aging is not a natural process but a disorder that can be treated and cured. His lab has shown that the information to be young is still present in old cells, it just needs to be reactivated. Using a combination of CRISPR and chemical compounds, they've restored vision in blind mice and reversed paralysis in mice with damaged optic nerves. The convergence of CRISPR with other technologies is accelerating everything. Artificial intelligence can now predict how genetic changes will affect lifespan with remarkable accuracy. Quantum computers, as mentioned earlier, could simulate the aging process at the molecular level, identifying intervention points we never knew existed. Nanotechnology could deliver CRISPR components directly to specific cells, editing our genomes from the inside out. We're approaching what some scientists call longevity escape velocity, the point where we can extend life faster than we age. If we can add more than 1 year of life expectancy for every year that passes, death becomes optional rather than inevitable. This might sound like fantasy, but consider that human life expectancy has already doubled in the last 200 years. The difference now is that we're not just treating symptoms or preventing disease, we're hacking the source code of life itself. The first person to live to 150 might already be alive today. They might be listening to this right now. The question isn't whether we can defeat aging, is whether we're ready for a world where we have. Because make no mistake, the ability to edit our own genes, to reverse aging at will, to essentially become different versions of ourselves, represents a transformation of the human condition as profound as the development of language or the discovery of fire. We're on the verge of taking control of our own evolution, and the decisions we make in the next few years will echo through centuries, perhaps millennia to come. Chapter 7. Medicine and Neuroscience. Brain-computer interface. Advances. A paralysed man in Switzerland just typed a message with his thoughts at 90 characters per minute, nearly as fast as you can text on your phone. Another patient controlled a robotic arm so precisely that she could pick up a coffee cup and drink from it, something she hadn't done with her own arms in 15 years. These aren't feel-good stories from the distant future. They're happening right now in 2025, and they're just the beginning of a revolution that will fundamentally alter what it means to be human. Precision neuroscience, founded by former Neuralink executives, just published results from their first human trials that have the neuroscience community buzzing. Their Layer 7 cortical interface is a film thinner than a human hair that sits on the surface of the brain, reading electrical signals from thousands of neurons simultaneously. Unlike other brain implants that require drilling through the skull, this device can be inserted through a slit smaller than a grain of rice. The entire procedure takes less than 20 minutes, and the implant can be removed just as easily. What makes this breakthrough so remarkable isn't just the technology, it's what the technology revealed about consciousness itself. When researchers analysed the brain signals from these implants, they discovered something that challenges everything we thought we knew about how consciousness works. The brain doesn't generate consciousness like a computer generates calculations. Instead, consciousness appears to emerge from the interaction between the brain and the body, particularly from something called interoception, our awareness of internal bodily signals. Think about this for a moment. Your sense of being you, your very consciousness, might not originate in your brain at all. New research from the University of Sussex shows that conscious experience begins with how the brain interprets signals from your heart, your gut, your breathing, even your skin temperature. The brain is constantly predicting what these signals should be, and when reality doesn't match the prediction, consciousness emerges from that mismatch. It's like consciousness is the error correction mechanism of existence itself. This discovery is already changing how we treat disorders of consciousness. Patients in vegetative states who showed no behavioural signs of awareness were connected to brain-computer interfaces, and something extraordinary happened. Many of them were actually conscious, trapped in bodies that couldn't respond. Using these interfaces, they could answer questions, express preferences, even communicate with loved ones for the first time in years. One patient, unresponsive for 7 years, used the interface to tell his family he wasn't in pain and wanted to keep living. Another asked to listen to Tool, his favourite band. The implications for mental health are equally profound. Depression, anxiety, PTSD, these conditions all involve disrupted patterns of brain activity that we can now see and potentially correct in real time. Researchers at Johns Hopkins are using brain-computer interfaces to detect the neural signatures of depression before patients even realise they're sliding into an episode. The system can then stimulate specific brain regions to prevent the depression from taking hold. It's like having a pacemaker for your mood. But the technology is advancing so rapidly that we're already moving beyond medical applications. At the University of California, researchers have created a brain-to-brain interface that allowed 3 people to play Tetris together, using only their thoughts. One person could see the game screen, while the other 2 could see the falling blocks. They had to coordinate their thoughts to rotate and place the pieces correctly. They achieved an 85% success rate, proving that we can create a functional telepathic link between human minds. The military applications are causing both excitement and concern. DARPA is developing neural interfaces that would allow soldiers to control swarms of drones with thought alone or communicate silently on the battlefield. Pilots could fly aircraft at the speed of thought, making decisions faster than any enemy could respond. But this raises terrifying questions about the future of warfare. If we can control machines with our minds, can those machines control us back? Could an enemy hack into a soldier's brain interface and turn them against their own forces? Commercial applications are coming faster than anyone expected. Meta is developing non-invasive brain interfaces that can detect the words you're thinking before you speak them. Imagine texting without touching your phone, or translating your thoughts directly into any language. Apple has patents for brain interfaces that could let you control your entire digital life with thought alone. We're approaching a world where the boundary between mind and machine doesn't just blur, it disappears entirely. The strangest discoveries are coming from studies of anesthesia and psychedelics. When patients under anesthesia are monitored with advanced brain interfaces, we can see consciousness flickering in and out like a candle flame. But here's the weird part. Sometimes consciousness persists in forms we don't recognize. Patients report vivid experiences during periods when their brains showed no activity in regions we thought were essential for consciousness. It's as if consciousness can exist in ways our current science can't explain. Psychedelic research is revealing even more mysteries. When people take substances like psilocybin or DMT while connected to brain interfaces, their neural activity becomes more random, more chaotic. Yet they report experiences of profound clarity and meaning. The default mode network, the brain system associated with our sense of self, essentially dissolves. People report experiencing consciousness without a self, awareness without an I. These states might show us what consciousness looks like stripped of the ego, the narrative self that we usually mistake for who we are. The philosophical implications are staggering. If consciousness emerges from brain-body interactions, rather than from the brain alone, then artificial intelligence might never be conscious in the way we are, no matter how intelligent it becomes. But it also means we might be able to create new forms of consciousness by altering these interactions. Some researchers are already experimenting with artificial interoception, giving AI systems simulated bodily signals to see if something resembling consciousness emerges. We're also discovering that consciousness might not be binary, on or off, but exists on a spectrum with many degrees and types. Locked-in patients show one type of consciousness, dreamers another, meditators yet another. Brain interfaces are revealing that even in healthy awake people, different parts of the brain can have different levels of consciousness simultaneously. Your visual cortex might be highly conscious while your motor cortex operates unconsciously, all in the same moment. The most controversial research involves enhancing normal human consciousness. Scientists at MIT have shown that electrical stimulation of specific brain regions can temporarily boost IQ by up to 20%, enhance creativity, or even induce savant-like mathematical abilities. Professional gamers are already using transcranial direct current stimulation to improve their reaction times. Students are using it to enhance memory formation. We're approaching a world where cognitive enhancement through brain stimulation could become as common as coffee. Some researchers are going even further, suggesting that brain interfaces could allow us to experience entirely new forms of consciousness. Imagine having direct sensory experience of magnetic fields like birds do, or seeing in infrared like snakes. We could potentially download skills directly into our brains, matrix style, or share memories and experiences between individuals. The boundary between self and other, between individual consciousness and collective awareness, might become voluntary rather than fixed. But perhaps the most profound discovery is that consciousness itself might be the fundamental feature of the universe, not an emergent property of complex brains. This theory, called panpsychism, suggests that everything from electrons to galaxies has some form of experience or awareness. Brain interfaces might not be detecting consciousness so much as tuning into it, like a radio picking up waves that were always there. If this is true, then death might not be the end of consciousness, but simply a transformation into a different form of awareness. Chapter 8. Psychology and Behavior, Mind Control and Memory. Mysteries. Your brain is lying to you right now, not in some metaphorical sense, but literally creating false memories, altering your perception and rewriting your past experiences in real time. Scientists at McGill University just published research showing that gaslighting, the psychological manipulation technique, actually works because our brains are designed to be reprogrammed by social input. What we call reality is really just a consensus hallucination that can be hacked by anyone who understands the code. The discovery came from studying people in controlled gaslighting experiments, where researchers deliberately gave participants false information about events they had witnessed. Brain scans revealed something shocking. When someone you trust tells you something happened differently than you remember, your brain doesn't just doubt your memory, it actually rewrites it. The hippocampus, where memories are stored, shows the same activation patterns as when forming new memories. Your brain is literally editing your past to match what you're being told. This isn't a bug in human consciousness, it's a feature. Our brains evolved to prioritize social cohesion over objective truth because for most of human history, being cast out from the group meant death. So when the group says the berries are poisonous even though you remember them being safe, your brain updates your memory to match the consensus. In 2025, this mechanism is being exploited by social media algorithms, political propaganda, and even marketing campaigns that can literally change your memories of products you've used. But here's where it gets truly weird. Researchers at UC San Francisco discovered that memories aren't just susceptible to social manipulation. They can be completely fabricated using a technique called optogenetics. By stimulating specific neurons with light, scientists can implant entirely false memories in mice. The mice genuinely remember events that never happened, showing the same fear responses and behavioral patterns as if the events were real. Human trials are obviously off-limits for ethical reasons, but the mechanism appears identical in human brains. Even more disturbing, a study released last week showed that high-fat junk food can hijack your memory systems within just 4 days. Scientists fed mice a diet similar to what many Americans eat daily, high in processed fats and sugars, and watched their hippocampal neurons become hyperactive. The mice lost the ability to form new memories properly and showed signs of confusion about recent events. When researchers restored normal glucose levels, the neurons calmed down and memory function returned. Your diet is literally editing your ability to remember reality accurately. The implications for conditions like Alzheimer's are revolutionary. We used to think memory loss in dementia was like files being deleted from a hard drive, but new research suggests the memories are still there. We just can't access them. Scientists at MIT have successfully restored lost memories in mice with Alzheimer's by using light to stimulate specific neural pathways. The memories weren't gone, they were just disconnected. Human trials using focused ultrasound to achieve similar effects are showing promising early results. But memory is just the beginning of the psychological mysteries we're unraveling. Morning sickness, that miserable experience of pregnancy that affects 70% of pregnant women, turns out to be a sophisticated evolutionary defense system. UCLA researchers discovered it's not random nausea, is a precisely calibrated biological program that protects the developing fetus from potentially harmful foods. The timing, intensity, and specific triggers of morning sickness all correspond to critical periods of organ development in the fetus. Women who experience moderate morning sickness actually have lower rates of miscarriage and birth defects. The mechanism is fascinating. When a woman becomes pregnant, her immune system begins identifying foods that could contain pathogens or toxins harmful to the developing baby. It then triggers nausea specifically for those foods, creating an aversion that can last throughout pregnancy. It's so sophisticated that it can distinguish between similar foods based on tiny chemical differences. This is evolution programming behavior through physical discomfort, using the mother's body as a chemical detection system for the baby. Speaking of evolution shaping behavior, researchers have made a shocking discovery about autism. Rather than being a disorder or mistake, autism appears to be linked to rapid evolution of uniquely human brain regions. The same genes that gave humans our distinctive cognitive abilities, our capacity for abstract thought, complex language, and technological innovation, are the ones associated with autism. In essence, autism might be the price we pay for the evolutionary advances that made us human. Studies of autistic individuals show they often have enhanced abilities in pattern recognition, systematic thinking, and attention to detail. These traits would have been incredibly valuable in early human societies for tasks like tracking animals, identifying edible plants, or creating tools. The prevalence of autism has remained stable throughout human history, suggesting it's not a disease to be eliminated but a variation that provides advantages to the species as a whole. Silicon Valley has an unusually high rate of autism, and that's probably not a coincidence. It's where those cognitive differences are most valued. The way our brains process social information is also being completely revised. A massive study using brain imaging found that loneliness literally changes the structure of your brain. Lonely people have different patterns of white matter, the neural highways that connect brain regions. Their default mode network, the system active when we're not focused on the outside world, is hyperactive. They also show increased activity in regions associated with vigilance and threat detection. Loneliness doesn't just feel bad, it fundamentally rewires your brain for survival in isolation. But the most unsettling discoveries involve free will, or rather our lack of it. Neuroscientists can now predict with 80% accuracy whether you'll choose to move your right or left hand up to 10 seconds before you think you've made the decision. The conscious experience of choosing appears to be a post hoc narrative your brain creates to explain decisions that were already made by unconscious processes. Your brain decides, then you become aware of the decision, then you create a story about why you decided. Free will might be the ultimate illusion. This has profound implications for criminal justice, mental health treatment, and personal responsibility. If our decisions are made unconsciously before we're aware of them, can we really be held responsible for our actions? Some courts are already considering neuroscientific evidence in sentencing, recognizing that brain injuries or abnormalities can eliminate what we normally consider free choice. We're approaching a future where brain scans might be more important than testimony in determining guilt or innocence. The manipulation of behavior through environmental cues is reaching scary levels of sophistication. Casinos have long known that certain sounds, lights, and patterns can trigger compulsive gambling, but new research shows just how precisely behavior can be controlled. By analyzing millions of data points from online behavior, AI systems can now predict with 93% accuracy whether someone will make a purchase, click a link, or even fall into depression. We're not just tracked online, we're being programmed. The scariest part is how subtle the manipulation can be. Researchers found that showing people certain colors for just 30 milliseconds, too fast for conscious perception, can alter their mood and decision-making for hours afterward. The music playing in stores is carefully selected to alter your walking speed and increase purchase likelihood. Even the temperature and humidity in shopping environments are optimized to put you in a buying mood. Your environment is constantly programming your behavior below the threshold of awareness. But there is hope. Understanding these mechanisms gives us the power to resist them. Meditation has been shown to strengthen the prefrontal cortex, the brain region associated with conscious control and decision-making. People who meditate regularly are less susceptible to manipulation and show greater activation in brain regions associated with free will, if such a thing exists. Knowledge itself becomes a form of protection. Once you know how your brain is being hacked, you can start to build defenses. Chapter 8, Psychology and Behavior, Mind Control and Memory Mysteries. Your brain is lying to you right now. Not in some metaphorical sense, but literally creating false memories, altering your perception, and rewriting your past experiences in real time. Scientists at McGill University just published research showing that gaslighting, the psychological manipulation technique, actually works because our brains are designed to be reprogrammed by social input. What we call reality is really just a consensus hallucination that can be hacked by anyone who understands the code. The discovery came from studying people in controlled gaslighting experiments, where researchers deliberately gave participants false information about events they had witnessed. Brain scans revealed something shocking. When someone you trust tells you something happened differently than you remember, your brain doesn't just doubt your memory, it actually rewrites it. The hippocampus, where memories are stored, shows the same activation patterns as when forming new memories. Your brain is literally editing your past to match what you're being told. This isn't a bug in human consciousness, it's a feature. Our brains evolved to prioritize social cohesion over objective truth because for most of human history, being cast out from the group meant death. So when the group says the berries are poisonous even though you remember them being safe, your brain updates your memory to match the consensus. In 2025, this mechanism is being exploited by social media algorithms, political propaganda, and even marketing campaigns that can literally change your memories of products you've used. But here's where it gets truly weird. researchers at UC San Francisco discovered that memories aren't just susceptible to social manipulation, they can be completely fabricated using a technique called optogenetics. By stimulating specific neurons with light, scientists can implant entirely false memories in mice. The mice genuinely remember events that never happened, showing the same fear responses and behavioral patterns as if the events were real. Human trials are obviously off limits for ethical reasons, but the mechanism appears identical in human brains. Even more disturbing, a study released last week showed that high-fat junk food can hijack your memory systems within just 4 days. Scientists fed mice a diet similar to what many Americans eat daily, high in processed fats and sugars, and watched their hippocampal neurons become hyperactive. The mice lost the ability to form new memories properly and showed signs of confusion about recent events. When researchers restored normal glucose levels, the neurons calmed down and memory function returned. Your diet is literally editing your ability to remember reality accurately. The implications for conditions like Alzheimer's are revolutionary. We used to think memory loss in dementia was like files being deleted from a hard drive, but new research suggests the memories are still there, we just can't access them. Scientists at MIT have successfully restored lost memories in mice with Alzheimer's by using light to stimulate specific neural pathways. The memories weren't gone, they were just disconnected. Human trials using focused ultrasound to achieve similar effects are showing promising early results. But memory is just the beginning of the psychological mysteries we're unraveling. Morning sickness, that miserable experience of pregnancy that affects 70% of pregnant women, turns out to be a sophisticated evolutionary defense system. UCLA researchers discovered it's not random nausea, it's a precisely calibrated biological program that protects the developing fetus from potentially harmful foods. The timing, intensity, and specific triggers of morning sickness all correspond to critical periods of organ development in the fetus. Women who experience moderate morning sickness actually have lower rates of miscarriage and birth defects. The mechanism is fascinating. When a woman becomes pregnant, her immune system begins identifying foods that could contain pathogens or toxins harmful to the developing baby. It then triggers nausea specifically for those foods, creating an aversion that can last throughout pregnancy. It's so sophisticated that it can distinguish between similar foods based on tiny chemical differences. This is evolution programming behavior through physical discomfort, using the mother's body as a chemical detection system for the baby. Speaking of evolution shaping behavior, researchers have made a shocking discovery about autism. Rather than being a disorder or mistake, autism appears to be linked to rapid evolution of uniquely human brain regions. The same genes that gave humans our distinctive cognitive abilities, our capacity for abstract thought, complex language, and technological innovation are the ones associated with autism. In essence, autism might be the price we pay for the evolutionary advances that made us human. Studies of autistic individuals show they often have enhanced abilities in pattern recognition, systematic thinking, and attention to detail. These traits would have been incredibly valuable in early human societies for tasks like tracking animals, identifying edible plants, or creating tools. The prevalence of autism has remained stable throughout human history, suggesting it's not a disease to be eliminated, but a variation that provides advantages to the species as a whole. Silicon Valley has an unusually high rate of autism, and that's probably not a coincidence. It's where those cognitive differences are most valued. The way our brains process social information is also being completely revised. A massive study using brain imaging found that loneliness literally changes the structure of your brain. Lonely people have different patterns of white matter, the neural highways that connect brain regions. Their default mode network, the system active when we're not focused on the outside world, is hyperactive. They also show increased activity in regions associated with vigilance and threat detection. Loneliness doesn't just feel bad, it fundamentally rewires your brain for survival in isolation. But the most unsettling discoveries involve free will, or rather, our lack of it. Neuroscientists can now predict with 80% accuracy whether you'll choose to move your right or left hand up to 10 seconds before you think you've made the decision. The conscious experience of choosing appears to be a post hoc narrative your brain creates to explain decisions that were already made by unconscious processes. Your brain decides, then you become aware of the decision, Then you create a story about why you decided. Free will might be the ultimate illusion. This has profound implications for criminal justice, mental health treatment, and personal responsibility. If our decisions are made unconsciously before we were aware of them, can we really be held responsible for our actions? Some courts are already considering neuroscientific evidence in sentencing, recognizing that brain injuries or abnormalities can eliminate what we normally consider free choice. We're approaching a future where brain scans might be more important than testimony in determining guilt or innocence. The manipulation of behavior through environmental cues is reaching scary levels of sophistication. Casinos have long known that certain sounds, lights, and patterns can trigger compulsive gambling, but new research shows just how precisely behavior can be controlled. By analyzing millions of data points from online behavior, AI systems can now predict with 93% accuracy whether someone will make a purchase, click a link, or even fall into depression. We're not just tracked online, we're being programmed. The scariest part is how subtle the manipulation can be. Researchers found that showing people certain colours for just 30 milliseconds, too fast for conscious perception, can alter their mood and decision-making for hours afterward. The music playing in stores is carefully selected to alter your walking speed and increase purchase likelihood. Even the temperature and humidity in shopping environments are optimized to put you in a buying mood. Your environment is constantly programming your behavior below the threshold of awareness. But there is hope. Understanding these mechanisms gives us the power to resist them. Meditation has been shown to strengthen the prefrontal cortex, the brain region associated with conscious control and decision-making. People who meditate regularly are less susceptible to manipulation and show greater activation in brain regions associated with free will, if such a thing exists. Knowledge itself becomes a form of protection. Once you know how your brain is being hacked, you can start to build defenses. Chapter 8: Psychology and Behavior, Mind Control and Memory, Mysteries. Your brain is lying to you right now, not in some metaphorical sense, but literally creating false memories, altering your perception, and rewriting your past experiences in real time. Scientists at McGill University just published research showing that gaslighting, the psychological manipulation technique, actually works because our brains are designed to be reprogrammed by social input. What we call reality is really just a consensus hallucination that can be hacked by anyone who understands the code. The discovery came from studying people in controlled gaslighting experiments, where researchers deliberately gave participants false information about events they had witnessed. Brain scans revealed something shocking. When someone you trust tells you something happened differently than you remember, your brain doesn't just doubt your memory, it actually rewrites it. The hippocampus, where memories are stored, shows the same activation patterns as when forming new memories. Your brain is literally editing your past to match what you're being told. This isn't a bug in human consciousness, it's a feature. Our brains evolved to prioritize social cohesion over objective truth because for most of human history, being cast out from the group meant death. So when the group says the berries are poisonous even though you remember them being safe, your brain updates your memory to match the consensus. In 2025, this mechanism is being exploited by social media algorithms, political propaganda, and even marketing campaigns that can literally change your memories of products you've used. But here's where it gets truly weird. Researchers at UC San Francisco discovered that memories aren't just susceptible to social manipulation, they can be completely fabricated using a technique called optogenetics. By stimulating specific neurons with light, scientists can implant entirely false memories in mice. The mice genuinely remember events that never happened, showing the same fear responses and behavioral patterns as if the events were real. Human trials are obviously off limits for ethical reasons, but the mechanism appears identical in human brains. Even more disturbing, a study released last week showed that high-fat junk food can hijack your memory systems within just 4 days. Scientists fed mice a diet similar to what many Americans eat daily, high in processed fats and sugars, and watched their hippocampal neurons become hyperactive. The mice lost the ability to form new memories properly and showed signs of confusion about recent events. When researchers restored normal glucose levels, the neurons calmed down and memory function returned. Your diet is literally editing your ability to remember reality accurately. The implications for conditions like Alzheimer's are revolutionary. We used to think memory loss in dementia was like files being deleted from a hard drive. But new research suggests the memories are still there, we just can't access them. Scientists at MIT have successfully restored lost memories in mice with Alzheimer's by using light to stimulate specific neural pathways. The memories weren't gone, they were just disconnected. Human trials using focused ultrasound to achieve similar effects are showing promising early results. But memory is just the beginning of the psychological mysteries we're unraveling. Morning sickness, that miserable experience of pregnancy that affects 70% of pregnant women, turns out to be a sophisticated evolutionary defense system. UCLA researchers discovered it's not random nausea, it's a precisely calibrated biological program that protects the developing fetus from potentially harmful foods. The timing, intensity, and specific triggers of morning sickness all correspond to critical periods of organ development in the fetus. Women who experience moderate morning sickness actually have lower rates of miscarriage and birth defects. The mechanism is fascinating. When a woman becomes pregnant, her immune system begins identifying foods that could contain pathogens or toxins harmful to the developing baby. It then triggers nausea specifically for those foods, creating an aversion that can last throughout pregnancy. It's so sophisticated that it can distinguish between similar foods based on tiny chemical differences. This is evolution programming behavior through physical discomfort, using the mother's body as a chemical detection system for the baby. Speaking of evolution shaping behavior, researchers have made a shocking discovery about autism. Rather than being a disorder or mistake, autism appears to be linked to rapid evolution of uniquely human brain regions. The same genes that gave humans our distinctive cognitive abilities, our capacity for abstract thought, complex language, and technological innovation, are the ones associated with autism. In essence, autism might be the price we pay for the evolutionary advances that made us human. Studies of autistic individuals show they often have enhanced abilities in pattern recognition, systematic thinking, and attention to detail. These traits would have been incredibly valuable in early human societies for tasks like tracking animals, identifying edible plants, or creating tools. The prevalence of autism has remained stable throughout human history, suggesting it's not a disease to be eliminated, but a variation that provides advantages to the species as a whole. Silicon Valley has an unusually high rate of autism, and that's probably not a coincidence. It's where those cognitive differences are most valued. The way our brains process social information is also being completely revised. A massive study using brain imaging found that loneliness literally changes the structure of your brain. Lonely people have different patterns of white matter, the neural highways that connect brain regions. Their default mode network, the system active when we're not focused on the outside world, is hyperactive. They also show increased activity in regions associated with vigilance and threat detection. Loneliness doesn't just feel bad, it fundamentally rewires your brain for survival in isolation. But the most unsettling discoveries involve free will, or rather, our lack of it. Neuroscientists can now predict with 80% accuracy whether you'll choose to move your right or left hand up to 10 seconds before you think you've made the decision. The conscious experience of choosing appears to be a post hoc narrative your brain creates to explain decisions that were already made by unconscious processes. Your brain decides, then you become aware of the decision, then you create a story about why you decided. Free will might be the ultimate illusion. This has profound implications for criminal justice, mental health treatment, and personal responsibility. If our decisions are made unconsciously before we're aware of them, can we really be held responsible for our actions? Some courts are already considering neuroscientific evidence in sentencing, recognizing that brain injuries or abnormalities can eliminate what we normally consider free choice. We're approaching a future where brain scans might be more important than testimony in determining guilt or innocence. The manipulation of behavior through environmental cues is reaching scary levels of sophistication. Casinos have long known that certain sounds, lights, and patterns can trigger compulsive gambling, but new research shows just how precisely behavior can be controlled. By analyzing millions of data points from online behavior, AI systems can now predict with 93% accuracy whether someone will make a purchase, click a link, or even fall into depression. We're not just tracked online, we're being programmed. The scariest part is how subtle the manipulation can be. Researchers found that showing people certain colours for just 30 milliseconds, too fast for conscious perception, can alter their mood and decision-making for hours afterward. The music playing in stores is carefully selected to alter your walking speed and increase purchase likelihood. Even the temperature and humidity in shopping environments are optimized to put you in a buying mood. Your environment is constantly programming your behavior below the threshold of awareness. But there is hope. Understanding these mechanisms gives us the power to resist them. Meditation has been shown to strengthen the prefrontal cortex, the brain region associated with conscious control and decision-making. People who meditate regularly are less susceptible to manipulation and show greater activation in brain regions associated with free will, if such a thing exists. Knowledge itself becomes a form of protection. Once you know how your brain is being hacked, you can start to build defenses. As we drift through these final moments together, think about what we've witnessed tonight, an interstellar visitor hiding behind our sun that might reshape how we understand our place in the cosmos. 6,000 worlds orbiting distant stars, each one a mystery waiting to be solved. The promise of unlimited, clean energy from fusion, finally within our grasp. The ability to edit our own genetic code to reverse aging itself. Machines that can read our thoughts and perhaps soon share our consciousness. The troubling realization that our memories can be rewritten, our behavior programmed, our reality manipulated. Unexplained phenomena in our skies that governments can no longer ignore, and a climate system pushed to breaking points we didn't know existed. These aren't separate stories. They're chapters in the same cosmic narrative, the story of a species on the verge of transformation. We stand at a threshold between what we were and what we might become. The decisions we make in the next few years about how we use CRISPR, how we merge with artificial intelligence, how we respond to climate change, whether we reach for the stars or retreat into ourselves, these decisions will echo through centuries, perhaps millennia. Think about where you were listening tonight. Perhaps in bed, letting these mysteries wash over you as you drift towards sleep. Maybe on a long drive, watching the stars wheel overhead as you contemplate our place among them. Or possibly just going about your day, but now carrying with you the knowledge that we live in the most extraordinary time in human history. A time when the impossible becomes possible with such regularity that we barely pause to marvel at it. The universe has been patient with us, keeping its secrets for billions of years, but now, in this brief cosmic moment we call the 21st century, those secrets are revealing themselves with breathtaking speed. We are the generation that will witness first contact or confirm we're alone, will cure aging or accept mortality, will save our planet or watch it transform into something unrecognizable, will merge with our machines or maintain our biological heritage. These aren't distant possibilities for future generations. These are choices we're making right now. As consciousness itself becomes something we can measure, manipulate, and perhaps create, we face the deepest question of all. What does it mean to be aware in a universe that might itself be aware? Every discovery we've discussed tonight brings us closer to that ultimate mystery. Are we the universe coming to know itself? Are we alone in that knowing? And if we are not, what responsibilities come with that knowledge? Thank you for joining me on this journey through the frontiers of human knowledge. If these discoveries have sparked your curiosity, stirred your imagination, or even unsettled your comfortable assumptions about reality, please consider sharing this with someone who might appreciate wrestling with these profound questions. Hit that like button if you want to see more deep dives into the science that's reshaping our world. And subscribe with notifications on so you don't miss the next revelation, because at the pace things are moving, tomorrow's discovery might make everything we discussed tonight seem quaint. Remember, everything discussed tonight represents our current best understanding based on available evidence and peer-reviewed research. Science is a process of continuous discovery and revision. What seems certain today might be overturned tomorrow by new evidence. That's not a weakness of science, it's its greatest strength. Stay curious, stay skeptical, and never stop questioning. Until next time, as you drift off to sleep tonight, remember that you're made of star stuff, living on a tiny world orbiting an ordinary star in an unremarkable galaxy among trillions. Yet somehow, against all odds, you're here, You're aware, and you're part of the greatest story ever told, the universe coming to understand itself. Sweet dreams, and good night.